Welcome to Let's Get to the Marks. We're looking at alkanes and petroleum for AQA chemistry. This is from 2023 AS Chemistry Paper 2. We're looking at question 2 here. And yeah, let's get into it. Make sure you pause the video after reading the question and having a go before unpausing and watching the walkthrough. All right, this question's about fuels. Crude oil is separated into fractions by fractional distillation. State the meaning of the term fraction in this context. So what do we mean when we're talking about fraction? You might remember from GCSE or from your AS chemistry knowledge, there's different fractions like naphtha, you've got bitumen, you've got diesel, you've got fuel oil. These aren't just one compound. These are a mixture of similar compounds or a mixture of hydrocarbons with similar MRs or similar sized chain lengths. So you've got lots of different compounds, all with very similar MRs or chain lengths, and they're hydrocarbons, and they make up the different fractions. Obviously, they're separated by the fact that they have different boiling points, which are based on their MR or chain length. Anyway, this will score you 1 mark. Now let's move on. 2.2. Petrol for cars contains branched and cyclic alkanes produced by catalytic cracking. Identify the catalyst used in this process. Okay, this is an easy 1 mark question here, and you just got to learn it off by heart. You need zeolite for catalytic cracking. What is zeolite? Zeolite is a compound made of aluminium, silicon, and oxygen, so sometimes known as aluminosilicates, or yeah, aluminosilicates. Easier to just remember zeolite. Well, let's move on to 2.3. Now, for 2.3, the question is that 3-ether-4-methohexane is a branch chain alkane in petrol. Draw the skeletal formula of this alkane. So the first thing to start with here is the word hexane. This is the main chain or the longest chain. So you just want to make sure that you've got 6 carbons. So with the skeletal formula, I like to put dots or C's just to count them up. You can just use your finger and count it up. You should have 6 points, and I have there, so I can remove these C's. So make sure you've got 6 points, which stand for 6 carbons in your main chain. Now I'm going to identify the first side chain. So it's 3-ethyl. So I want to count 3 carbons along. So that's going to come off here. Now I can draw it going this way. I could draw it going that way, but I'm going to stick with the first option. So like that, that's an ethyl group because it then has 2 carbons coming off the side. And then on the 4th carbon, we just want one side chain, which is the methyl. So just one straight line. And that is the skeletal formula for 3-ether-4-methohexane. Right, zinging on to 2.4, just get this into focus. Give the equation for the complete combustion of 3-ether-4-methohexane. Use the molecular formula for 3-ethyl-4-methohexane in your equation. Once again, pause the video and have a go at writing out this combustion equation. You're going to get 1 mark for the correct molecular formula and 1 mark for balancing the equation. Okay, well, we know it's an alkane because of the name. It ends in ANE. We can also work out how many carbons. Hexane would have 6, but it's got a 3-ether and a 4-mether, so it's got 3 extra carbons, so it's C9. Now, you might remember the formula for alkanes. The general formula is CnH2n plus 2. So if it's C9, it's going to be H20. Now, we could have just worked it out by going through the skeletal formula, but easier to work it out like that. So we're going to write the combustion equation, and this is complete combustion, which means we don't get any carbon monoxide formed, we get carbon dioxide formed. And it's when we burn something in oxygen to form carbon dioxide and water. These are very common in AS chemistry, not so common in the full A level, but pretty common for you to have to do one of these. And they're fairly easy, really. So you should be looking to get both marks here. So we get the first mark for the C9H20. But the second mark's for balancing this combustion equation. So you just take the fact that there are 9 C's in the hydrocarbon, and that's going to give you 9 carbon dioxides. And that's always the case in these combustions. And then the fact that we have 20 hydrogens, I'm going to need 10 waters, 10 times H2 to make 20. So now I need to count up the oxygens on the right-hand side. I've got 18 from the 9 carbon dioxides. I've got another 10 from the waters. Add them together, that's 28 oxygen atoms in total. So I'll come back to the left, and with combustion equations, you always balance the oxygen last. And so I'm going to have 14 oxygen molecules. 14 times O2 is going to make 28. And there we go, that's the second mark. Awesome. So let's clear that move on to 2.5. Make sure you hit the like, share, subscribe. It really helps with the channel. If you're not hitting the like, guys, that's not very nice. And that makes you a deuterium, iodine, carbon, potassium. And you don't want to be one of them. Okay, 2.5. Carbon dioxide is a product from the combustion of petrol in cars. Carbon dioxide acts as a greenhouse gas when it absorbs infrared radiation. Give one reason why carbon dioxide absorbs infrared radiation. So there's certain type of molecules that are very good at absorbing infrared radiation, and it's when their bonds vibrate. Okay, now what's the reason why we get vibration in a carbon dioxide molecule? Okay, normally a non-polar bond, you don't get so much infrared radiation absorbed. But however, although it's a non-polar molecule because it's symmetrical, it does have a polar bond. So it has a delta positive carbon and a delta negative oxygen. And so they're going to absorb infrared radiation. And the reason why they absorb infrared radiation is because it's a polar bond, 1 mark, and therefore it vibrates 2 marks. And even better if you say, well, it vibrates at the same frequency as infrared radiation, which is why it can absorb infrared radiation. Okay, so the polar bonds vibrate at the same frequency as infrared radiation. But you will just get the mark for saying, hey, it's a polar bond and therefore it vibrates, and that will get you the mark. Make sure you don't call it a polar molecule because it's a linear molecule and the polar bonds cancel each other out overall. So overall, the molecule is not polar, even though the bonds, individual bonds within it are. Okay, let's move on to 2.6. Once again, pause the video, have a read and have a go. Nitrogen monoxide is formed when petrol is burned in cars. State one environmental problem that NO, or nitrogen monoxide, causes. State what is used to remove nitrogen oxide from exhaust gases formed in petrol fuel cars. So the environmental problems, there's like 4 different answers you can give here. Nitrogen oxides, so that's dioxide, trioxide, or monoxide, cause respiratory illness. They cause breathing difficulties, basically. And they also form acid rain. So any of the nitrogen oxides can dissolve in water in clouds, react with the water to form HNO3, aqueous, which is nitric acid, which is acid rain. And they can also form smog and ground level ozone. How do we remove nitrogen monoxide from cars? We remove them with catalytic converters using those precious metals like platinum and stuff. And what happens is it reverses the nitrogen oxides like nitrogen monoxide and converts them back into nitrogen and oxygen like they originally were in the air. Remember, this pollution forms from the heat of hot car engines. So you're just returning them back to being pure nitrogen and oxygen in the air with a catalytic converter. And that will get you 2 marks. Right, 2.7. I think this is the final question. Petrol sold in the UK contains 10% bioethanol. Bioethanol is like alcohol that's made from crops by fermentation and is seen as carbon neutral. State what's meant by the term carbon neutral. So a carbon neutral crop is one because when it photosynthesizes, it absorbs CO2. So 6 molecules of CO2 are absorbed during photosynthesis. And when you do fermentation and combustion, you combine those 2 equations together, you release 6 carbon dioxide. So overall, there's net no overall release of carbon dioxide to the atmosphere. So it's carbon neutral. So if you weigh up the amount of carbon dioxide absorbed by photosynthesis, it's equal exactly to the amount of carbon dioxide released in fermentation and combustion from 1 molecule of glucose. And that's your lot. That's the end of this question. Don't forget to hit the like, share, subscribe. Let's get to the marks. I'll see you in the next video.
You're still here? It's over.